Okay. So we'll start with oscillation. First, we'll discuss about that oscillation. Then we'll go to wave. Okay. Then at the end, we'll go to optics. So basically, oscillation and waves two are different thing. Okay. So the first discussion about that oscillation is what is actually oscillatory motion. Okay. So oscillatory motion is basically to and fro motion, right? I'll give a real example. Suppose आपके पास एक कटोरा है, ओके, एंड एक आपका बॉल है, आपने इसका मेन जो पोजीशन में यहाँ पे आपने इस बॉल को रखे हो, ओके. नाउ इफ यू displace this ball slightly, okay, then what will happen? This ball will go like this, then it will come to equilibrium position, then it will go to this, again it will come to equilibrium position, again it will go to this side, again it will come to equilibrium position. So this is a kind of true to and fro motion, right? Motion along this side, then motion along this side, then it will come to mean position, it will go to right side. Also another example is you have spring mass system. Suppose you have a string having string constant k, and you attach a block having mass m. Now let us assume this is the equilibrium position. Okay. Now if you displace this block by applying small amount of force, then what will happen? This block will start motion like this. So this is a kind of to and fro motion. Is this part clear? So the equation for oscillatory motion. So equation for oscillatory motion is basically F equals to minus k x की power n, where n can run on 3, 5. Only that odd integer is allowed. Okay. So this is the equation for oscillatory motion. So F is the force acting on that particle equals to minus k. I'll discuss what is k. X की power n. What is x? X is the displacement from the equilibrium position. Let us assume, suppose you have a system. Let us assume this is your equilibrium position. Equilibrium position means, let us take this is x equals to 0, and you have a particle having a mass m. You displace this particle along positive x direction. Let us take this is your positive x direction. So if you displace this particle by applying a small amount of force, then what will happen? There will be a force that will act in the opposite direction of displacement. Okay. So F equals to minus k x to the power n. So force will always be opposite towards the direction of displacement. You can check. Suppose आपने positive x की तरफ displace किए हो, so what will be the force? F equals to minus k x की power odd number, because n is here on 3, 5. So if you are displacing this particle, force will act in which direction? So you have displaced this particle. Let us assume this is your displacement from mean position. Okay. So force will act on the opposite direction. If you displace this particle from mean position on the negative side, then what will happen? In which direction force will act? The force will act opposite to the displacement. You can check here also. Let us take x is now minus x, right? Because this is the origin. You have displace that particle from origin to the negative direction or along negative x direction. So you have to keep x is minus x. So for this case, what will happen? F equals to minus k. Then you have to keep x is minus x to the power n. And n, what is n here? N is some odd number on 3, 5. So what will happen? So minus minus x to the power odd number, it means it will give you minus, right? So basically your force will be, what will be the force formula now? X to the power n. What does it mean? It means that force, when you are displacing that particle along negative x direction, force is actually acting along positive x direction. So what is the important part of that oscillatory motion? That force will always act opposite to the displacement. If you are displacing that particle along positive x direction, force will act along negative x direction. If you are displacing that particle along negative x direction, force will act towards positive x direction. Okay. So in oscillatory motion, पार्टिकल हमेशा क्या हो रहा है, एक पोजीशन की तरफ जाना चाह रहे हैं. देखो जब आप पार्टिकल को मीन पोजीशन से पॉजिटिव एक्स की तरफ मूव करना चाह रहे हो बाय अप्लाइंग स्मॉल अमाउंट ऑफ फोर्स, द पार्टिकल इज ट्राइंग टू गो एक्चुअली टुवर्ड्स मीन पोजीशन. इफ यू आर applying that force to move that particle from mean position to negative x direction, the force is acting and particle is trying to move towards mean position. So the important features of oscillatory motion, that particle is always trying to go to a particular point. That point is basically known as equilibrium point or stable point. So this is the important feature of oscillatory motion. So this is the stable point, or you can write equilibrium point. Is this part clear to all what I'm saying?
Yes, sir.
Okay. Is there any doubt?
No, sir.
Okay. Okay. Now, what is simple harmonic motion and why it is so important in physics? Because wherever you will go to classical mechanics or quantum mechanics, everywhere you will look to simple harmonic motion. So why it is so important in physics, not only in physics, but in real life also. That's the important thing. So what is actually simple harmonic motion? So I'll write that notation for simple harmonic motion, that is SHM. Okay. So simple harmonic motion is the simplest case of oscillatory motion. So you know that for oscillatory motion, you got this equation, right? F equals to minus k x to the power n. And n was on 3, 5, and so on, all odd integers. Now for simple harmonic motion, it is the simplest case of oscillatory motion. What is the meaning of simplest case of oscillatory motion? It means when you will take n is small number. I mean, small number is allowed, that is 1. So for simple harmonic motion, F equals to minus kx. Okay. So F equals to minus kx. Why it is simple harmonic motion? Because if you are taking large number of x, suppose you are n, suppose you are taking n value 3, 5, then that case will really be complicated, and that will be non-linear case. Okay. So this is the actually simplest case. And why it is important in physics, not only in physics, in real life also. Why? Because anyone, why it is so important? Because wherever you will go to quantum mechanics, you will get simple harmonic motion. If you go to classical mechanics, there also you will get that simple harmonic motion. So why it is so important? Anyone? So it is important because in solid, solid is actually made up of large number of atoms, and atoms are actually connected by imaginary string, right? Not only solids. So what I'm saying, I am giving two atoms, they are actually connected by spring, and you have many number of atoms in solid, and all are connected by a imaginary string, and their vibration actually is simple harmonic motion. So properties of solid basically governed by that simple harmonic motion. Not only this, if you go to molecular physics, molecules are connected by imaginary spring. So the properties of molecular physics, like if you go to vibrational spectra or anharmonic oscillator, all these things are basically depends upon these. So that's why it is so important in physics as well as in real life. Okay, so that's why scientists everywhere they are trying to focus on simple harmonic motion. Okay, so what does it mean? F equals to minus kx, as I already discussed you. Suppose you have a spring mass system. So best example of simple harmonic motion is spring mass system. You have many examples, but let us take that example for the sake of time being. So suppose you have a spring, okay, its spring constant is k, and you have a block. And let us take this is the equilibrium position, and let us take this position is x naught. Let us assume x equals to 0. Now, if you displace this particle by small amount, so to displace this particle, so please keep in mind, so if you are when you are displacing this particle, so it is at equilibrium position, there is no force on this particle or on this block. But to displace this particle, you have to give some initial force, right? So you are giving some force to displace this particle, but there is one force is acting that is opposite to that displacement. That is basically known as the rest F equals to minus kx. So if you try to stress this particle or stress this spring, force will act to oppose this stretching. If you try to compress this spring by applying force, then this force is actually trying to oppose this compression. Okay, so this is very simple equation. Now I can write force. Force is nothing but what? M, or I can write ma, right? Ma equals to minus kx, and a is acceleration, m is the mass, so I can write acceleration is equals to minus k by m, and you have x. And k by m is nothing but omega square, right? So this is basically omega square x. Now I should mention what is k. K is basically what? K is basically spring constant. Okay. K is basically spring constant, and omega is not frequency. Please keep in mind, this is actually angular frequency. Okay. Angular frequency. Okay. Is this part clear to all? Is this part clear to all?
Yes, sir.
Angular frequency is, sir.
Omega is angular frequency. Okay. So the A is the acceleration. So acceleration is the acceleration of a particle, that is minus omega square x. Okay. So this is an important equation. So acceleration of simple harmonic motion is minus omega square x. Omega is the angular frequency. X is the displacement of particle from equilibrium position or stable position. Now again I'll write that equation, previous equation. F equals to was minus kx, right? So I can write this equation as force is nothing but m del square x by del t square equals to minus kx. Okay. So further I can write del square x by del t square equals to minus k by m into x, and k by m is already we have discussed, that is omega square. So this is the differential equation, del square x by del t square plus omega square x, that is 0. So this is the differential equation of simple harmonic motion. This is the differential equation of SHM. Okay. So if you solve it, I am not going to derive that solution, because in mathematical physics, if people will learn that solution how to solve this thing, but for this time it is not necessary to solve. So if you solve this equation, you will get the displacement of a particle or displacement of simple harmonic motion x, that will be a sine of omega t plus phi. So this is the displacement of simple harmonic motion. Okay, and actually this is the solution of this differential equation. So what is A? A is basically amplitude. Okay, and phi is basically initial phase. Okay, if the particle is starting motion from equilibrium position, then phi will be how much? If the particle is starting motion from equilibrium position, then phi will be 0. If particle start motion from equilibrium position, and you know what is equilibrium position, right? So is this part clear to all what I am saying? Is this part clear to all? Because after 10 minutes we will go to that advanced part, then it will be difficult. Is this part clear to all?
Yes, sir.
Okay.
Yes, sir.
Okay. So you got the displacement of the particle or simple harmonic motion from equilibrium position, that is a sine omega t plus phi. And you can clearly see that x is a function of time, right? Because sine omega t plus phi itself a function of time. So displacement of particle itself a function of time. And it's oscillatory, because sinusoidal function is oscillatory in nature, right? So this displacement is oscillatory in nature. Now if you know that displacement, then you can calculate that velocity, right? So you should mention here x is actually displacement. Okay. Displacement from where? From equilibrium position. Now what will be the velocity? So velocity is nothing but rate of change of displacement, or time rate of change of displacement. So if you differentiate this equation with respect to time, so you will basically get a omega cos of omega t plus phi, right? So what I can write a omega square root of 1 minus sine square omega t plus phi. Right? This part clear, right? Now further I can substitute that value of sine omega t. So sine omega t is nothing but x by a. So this terms will be x square by a square. So if you solve it, you basically will get omega square root of 1 minus x by a ka whole square. Okay. So you will get omega square root of a square minus x square. Okay. So this is your velocity of particle. Now you can clearly see that velocity is a function of displacement, right? Now if you plot the trajectory between velocity and displacement, how it will look like? So what I'm saying, आप लोगों ने लिख लिया इतना? Have
Yes,
you
sir.
written? Okay. Now what I'm saying, if you draw the trajectory between, or if you plot the curve between velocity and displacement, so how it will look like? What I'm saying, if you draw the curve, like let us take this side, you have velocity of simple harmonic motion, and this side you have displacement. So how it will look like? So this equation, from this equation you can guess, because you have v is how much? V is omega square root a square minus x square, right? So if you simplify this equation, you will get v by omega square equals to a square minus x square. So if you further simplify this equation, you will get v square by omega square a square plus x square by a square, that is equal to 1. So this is the equation of what? This is the equation of ellipse, right? So this is the equation of ellipse, because x square by a square plus y square by b square. Here y is basically you have taken velocity. So this equation itself is saying, if you plot a trajectory between velocity and the displacement of simple harmonic motion, then that trajectory will be basically ellipsoid. Is this part clear what I'm saying?
Yes.
Okay. So this point will be basically will be a, this will be minus a, this will be omega a, and this will be minus of omega a. Okay. Okay. Now you have three equations. You have acceleration, velocity, and also displacement. Now we'll see where that velocity will be maximum, where the acceleration will be maximum. So let us draw that complete diagram. Let us assume this is the mean position, and that position is at x equals to 0. Let us take the amplitude of oscillation of SHM is a. Okay. So this is the mean position. And you know that equation, acceleration was how much? Minus omega square x. And you have velocity, that was omega root over a square minus x square. And x is basically the displacement from equilibrium position. So this is the equilibrium position, and this is the extreme position. This is the positive extreme position, and this is the negative extreme position. Okay. Now you see where the velocity will be maximum. Where the velocity will be maximum? When you see v
X
equals
will
to
0.
omega root over
X
a
equal to
square minus
0.
x square. So when x is 0, then this term will be maximum, right? That means this means also this means what? At equilibrium position you will have v equals to v max. Okay. And here how much the velocity will be? At this extreme position, v will be how much? X is what? At extreme position, x will be how much? A, right?
Amplitude.
Amplitude, exactly. So at this position, v will be how much? 0. So at extreme position, you will have velocity how much? 0, right? Because you have to substitute x equals to a here. No.
Yes, sir.
You substitute x equals to a, because at extreme position, x is nothing but amplitude. So this is the displacement that time. So that means 0. Now what about acceleration? What about acceleration? So if you see that acceleration, it depends upon x, displacement. So at this position, you will have acceleration how much? 0, right? Here acceleration will be how much? A will be a max. Because I am taking only magnitude, so at this position, acceleration will be how much? Omega square m. I have taken only magnitude, okay? And this, at this extreme position, you will have acceleration that will be again maximum, and that will be again omega square a.
सर एक्चुअली एक्सेलरेशन एम्पलीट्यूड में कंफ्यूजन हो रहा है, तो इसे कैपिटल ए से लगा दीजिए सर थोड़ा.
Oh, okay, you can take it. That's a good thing. You can take, this is a capital A. This is a very good thing. You can take capital A also. Okay. You can take capital A also. But the concept is clear, right? The concept is clear, right?
सर ये समझ नहीं आया.
कौन सा समझ में नहीं आया?
ये वेलोसिटी यहाँ 0 है तो ये एक्सेलरेशन मैक्सिमम कैसे है?
वेलोसिटी 0 है तो एक्सीलरेशन मैक्सिमम कैसे है? दिस
हाँ.
इक्वेशन itself is saying that एक्सीलरेशन मैक्सिमम है. देखो यहाँ पे वेलोसिटी क्या है?
मैक्सिमम.
मैक्सिमम है. ये वेलोसिटी कहाँ से गेन हुआ है?
इक्वेशन से.
हाँ,
इक्वेशन से.
इक्वेशन से
V-
गेन हुआ है. ठीक है. जैसे आपका क्या हो रहा है, देखो एग्जाम्पल अच्छे से समझो, है ना. इस पॉइंट में ये आपका एक्सट्रीम पोजीशन है, सपोज मान लो ये आपका बेसिकली एक्सट्रीम पोजीशन है. यहाँ पे आपने कोई बॉल को छोड़ दी है ना. अब इसका क्या हो रहा है, एक्चुअली वेलोसिटी क्या हो रहा है, टाइम के साथ बढ़ रहा है, बढ़ते बढ़ते. बट एक्सीलरेशन क्या हो रहा है, 0 कम हो रहा है. इस पोजीशन में आके क्या हो रहा है, आपका वेलोसिटी मैक्सिमम हो रहा है, बट क्या है, एक्सीलरेशन कम हो रहा है. क्यों? क्योंकि बेसिकली फोर्स जो है, फोर्स इक्वेशन क्या बोलता है, माइनस के एक्स, राइट. एंड एक्स इज व्हाट, एक्चुअली एक्स इज द डिस्प्लेसमेंट फ्रॉम मीन पोजीशन, राइट. तो मीन पोजीशन से जितना दूर जाओगे आप, उतना ही आपका एफ बढ़ेगा, फोर्स बढ़ेगा. अगर फोर्स ज्यादा है तो एक्सीलरेशन भी ज्यादा है, बिकॉज एफ इक्वल्स टू एम है. ठीक है ना.
यस.
तो ये जो वेलोसिटी बढ़ रहा है पार्टिकल का, क्योंकि वो एक्सीलरेशन का बढ़ते बढ़ते यहाँ पे एक्सीलरेशन कम हो गया, बट दिस एक्सीलरेशन के कारण उसने ऑलरेडी बहुत सारे वेलोसिटी गेन कर लिया है. सेम थिंग इज हैपनिंग इनसाइड दैट. इफ यू मेक टनल इनसाइड द अर्थ, व्हेन आई विल गो टू दैट डिस्कशन, दैट टाइम आई विल डिस्कस. तो यहाँ पे आपका एक्सीलरेशन जैसे बढ़ रहा है, उसके कारण आपका क्या हो रहा है, बेसिकली एक्सीलरेशन के कारण आपका वेलोसिटी ज्यादा हो रहा है. Although acceleration is decreasing with decreasing x, but acceleration कुछ तो है ना, उसके कारण क्या हो रहा है, आपका वेलोसिटी बढ़ रहा है. At this position acceleration is becomes 0, but due to this journey this particle already gained so much of velocity. That's why at this position or equilibrium position the particle will have maximum velocity, and at this position force will be minimum or 0, and acceleration will also be 0. Okay, so this is a very good thing. You can clearly check from this equation itself. Now is this picture clear to all what I'm saying?
यस सर.
Okay, now if the particle is displacing along this side, so what will be the acceleration direction?
बढ़ेगा सर.
Acceleration का direction किधर होगा भाई? It will be along this direction, right?
Opposite.
Because force will be along this direction, and force is basically defined the direction of acceleration, because force is nothing but m into a, right? तो force का जिधर direction होगा, acceleration का direction भी उधर ही होगा. If the particle is moving in this direction, what will be the direction of force? In this direction, right? So the direction of acceleration will also be in this direction. Is this part clear what I'm saying? Is this part clear?
Yes, sir.
Yes, sir.
Now if the particle is going this side, then force will act,
Opposite direction.
force will act in this direction, so acceleration direction will be like this. Okay, is this part clear? It's a very simple thing but very conceptual, because these things used to ask in jest, you know, where the acceleration will be maximum, where it will be minima. So sometimes it look like the velocity at the equilibrium position is maximum, so acceleration will also be a maximum, but this is not true, because your famous equation, this equation itself is saying that at extreme position you will have maximum acceleration, and at equilibrium position you will have maximum velocity, and also at equilibrium position you will have force equals to 0. Okay.